nothing but b of x. Then it is coined as polynomial equation. X to y or y to x, whatever the intersecting point I'm going to get, that is known as root of the given equation. In the iterative method, whatever the equation I'm going to have, that is represented in the form of f of x. Hello to all, a warm welcome to my new session on roots of equation. I am Revati from the Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So dear student, before going to start my today's session, let me to recall the topic what I have discussed in my previous session of this chapter. So dear student, I started with how to perform addition as well as subtraction of floating point numbers. Along with that, I have covered errors in numbers. So there are three types of errors: absolute error, relative error and percentage error. Along with that, I have discussed some of the problems under errors in numbers. But now in my today's session, I'm going to deal with introduction about roots of an equation. Along with that, I'm going to deal with types of equation. In that, I'm going to deal with iterative method as well as problems under iterative method. So what is roots of an equation? So dear student, if I consider any equation, for each equation we are going to have the root. Now suppose if I want to find out the root, what I want to do, I want to consider x-axis as well as y-axis. So the real root of an equation, that is represented in the form of f of x, that is always equal to 0, where the graph f of x meets x-axis and real number alpha is called the real root of the equation. Only f of x equal to 0 if and only if f of alpha is also equal to 0. So dear student, to illustrate this concept, let me to consider f of x. So what is f of x? That's nothing but the real root of an equation. So I have the equation 2x square minus 11x plus 5. Now tell me what is x. Before that, let me to graph plot for this equation. Think that I have x-axis and I have y-axis. So this is my y-axis and this is my positive y-axis and this is my positive x-axis, and this one my negative x-axis and this one my negative y-axis, and this is nothing but the 0. Now this right side is positive x-axis, so I'll start from 1, 2, 3, 4 and 5, and this is also positive. Instead of taking 1, I'll make it 5, 10, it is 15. Now towards down it is minus 0.5, minus 10, minus 15. And if I consider minus x, minus 1, minus 2 and minus 3 and so on. Now this is my equation. Now I want to find out x value. Okay, so what I'm going to do, I'm going to use trial and error method. So I'm going to start substituting x equal to 0. Now when x equal to 0. And what about y? That means I want to find out y. So what I will do, 0 square, that is 2 into 0 square minus 11 into 0 plus 5. So it is how much? Plus 5. That means when x, so x is 0, what about y? Y is plus. Now randomly I will take x equal to 2. So 2 square minus 11 into 2 plus 5. So it is 4 minus 22. So it is minus 18 plus 5. So minus 18 plus 5, the answer is minus 13. So when my x is 2, so this is positive x 2. And what about y? Y is minus 13. So somewhere it is minus 13. Now I'm going to substitute x equal to 5. So 2 to the power 5 minus 11 into 5 plus 5. So 2 to the power 5 in the sense what? 2 into 2 into 2 into 2. That is 2 to the power 5 equal to 32 minus 55 plus 5. So minus 55 plus 5. What is the answer? It is minus 18. That means when my x is 5, my y is minus 18. Now, if I draw the line, okay, this intersecting points itself known as roots of given equation. So, when I draw the line from x to y or y to x, whatever the intersecting point I'm going to get, that is known as root of the given equation. So, what is the formula used to find out root of the given equation? What I want to do? I want to start substituting the x value in order to find out y value. Now, moving on to type of equation. So, if I consider polynomial equation. So, what is polynomial equation? The equation which is represented in the form of p of x. Okay, whatever the equation it may be, but it is represented in the form of polynomial. That is nothing but p of x. Then it is coined as polynomial equation. Now, this polynomial equations are further divided into three different types, that is linear equation, quadratic equation and cubic equation. So what is linear equation? Linear in the sense what? I have two variables, that is a and b. But what about x value? That is the power of x is 1. So this kind of equations are termed as linear equation. The best example, 2x plus 5 or 10x minus 2, etc. Now, quadratic equation, when my x power is 2, quadratic in the sense what? It is 2. When my x value is 2, so the equation that is in the form of ax square plus bx plus c equal to 0, where a is always not equal to 0. Example, think that 10x square plus 5x plus 3 equal to 0. And this kind of equations are called quadratic equation. Then what about cubic equation? Cubic in the sense what? Cube. So here cube is nothing but 3. So power of 3. If I consider, if I am having 4 variables and I am having the power 3, then it is termed as cubic equation. For example, think that x to the power 3 plus x square plus x plus some constant value. For example, say 10, or I'll make it d. So it is ax cube, bx square, cx plus d equal to 0. And this kind of equations are called cubic equation. Now, I'm going to have the iterative method. So, what is iteration or iteration? I'm going to repeat the same step again and again. And this is one kind of trial and error method. I don't know when and where to stop, but I'm trying to get the solution by using trial and error method. And in the iterative method, whatever the equation I'm going to have, that is represented in the form of f of x. I repeat, in the iterative method, whatever the equation I'm going to have, that is represented in the form of f of x. This same f of x can be rewritten in the form of pi of x. Okay, I repeat, the same f of x can be rewritten in the form of pi of x. For example, think that if this is x1 and if this is x0, for the next iteration it is x2 equal to pi of x1. For the next iteration, x cube equal to pi of x2, and it's going to continue when xn plus 1 equal to x of n. Now, this same pi of x can be rewritten in the form of pi dash of x inside the mod that must be less than 1. And these are the certain condition I want to follow while I'm going to use iterative method. So, whatever the equation I'm going to get, that is represented in the form of f of x. This f of x can be rewritten as pi of x, and the successive approximations are given by x2 is nothing but pi of x1, here x3 is nothing but pi of x2, and so on. Now, I'm going to have some of the problems under this iterative method. What is my first problem? That is, find the root of x cube plus x minus 1 is equal to 0 by iterative method, given that root lies nearer 1. So, in the question directly they specified that the root lies between, or which is nearer to the 1. So, where we are going to get the root which is nearer to the 1. So, what I want to do, first I want to represent the equation in the form of f of x. So, what I will do, I'll write f of x equal to x cube plus x minus 1. Now, if I consider this one, I want to simplify this equation, what I'm going to do, I'm going to group x3, that is x to the power 3, that is x cube plus x in one group and 1 is in another group. Now, if I see this one, what is common here? That is x. So, what I'm going to do? I'm going to take x outside. So, x square plus 1 equal to 1. And when I simplify, I will get x equal to 1 divided by x square plus 1. Now, this is my pi of x. That means, as I discussed, the same f of x can be rewritten in the form of pi of x. That means, this f of x can be rewritten in the form of pi of x. And what is x naught? In the question, they mentioned that the root lies nearer to 1. So, x naught is 1. And what I'm going to do? I'm going to substitute in my equation. So, instead of writing x square, what is the value? I'm going to substitute, that is 1. So, I'll get 1 by 2 and when I divide, I'll get 0.5. And this is the value for my next iteration. So, here x2 equal to pi of x1. So, what is x1? It is 0.5. And when I substitute this one in this equation, I'm going to get the answer 0.5. Now, in my next iteration, that is x of 3. And which value I'm going to consider? That is 0.8. I'm going to consider 0.8. And when I substitute 0.8 in this equation, I'm going to get 0.6. Now, in the next iteration, I'm going to consider 0.6 and when I substitute, I'm going to get 0.7. And for the fifth iteration, I'm going to consider previous x value. There's nothing but x4. So, what is x4? It is 0.7. And when I substitute that one in this equation, I'm going to get the answer 0.6. So, further if I continue, the same steps are repeating. So, what I'm going to do? I'm going to stop the iteration and I'm going to write the final answer that the approximate root for the given equation is 0.6. Now, I'm going to have my second problem, that is find the real root of cos x equal to 3x minus 1 and the root lies between 0 and pi by 2. So, in the question, they directly mentioned that the root lies between at the 2 point, that is 0 and pi by 2. Now, let me to find the solution here. So, what is my first line here? That is nothing but I want to represent the equation in the form of f of x. So, I have written f of x. I'm going to bring cos x here. So, cos x minus 3x plus 1. Now, I'm going to substitute the value because here I have two roots. For that, what I'm going to do? I'm going to substitute the value. And when I substitute cos of 0, I'm going to get 1 and minus 3x. That is, x is 0. 3 into 0, it is 0 and I have 1. So, answer is 2. That means, when x is 0, what's the answer? It is 2. Now, I have pi by 2. So, what is pi here? That is nothing but 180 degree divided by 2. It's nothing but 90. So, dear student, cos 90 is nothing but 0 minus 3 into 90. So 3 into 90 in the sense what? It is 0 minus 270 and plus 1. So I'm going to get negative sign, that is minus 26. What is the answer? That is minus 269. Now, dear student, when my x is 90 degree, then I'm going to get minus 269. So, this is the actual given equation. Now, to simplify this equation, what I'm going to do? I'm going to bring 3x outside, that is left side. Now, I have cos x plus 1. Further simplifying this one, I will get x equal to cos x plus 1 divided by 3, that is nothing but pi of x. That means the f of x can be written in the form of pi of x. Now, dear student, when I substituted f equal to 0, I got positive answer, and when I substituted f of 90, I got negative answer. And what I want to take, I want to consider only the positive root. For that reason, I'm going to take x naught equal to 0. Now, x1 equal to cos of 0 plus 1. So, cos of 0 in the sense what? That is 1 plus 1, 2 divided by 3. I'm getting 0.6667. Now, this is the next x value. This is the x value for next iteration. So, I'm having cos of 0.6667 plus 1, and when I divide, I'll get 0.6666. Now, this value is the input for next iteration, and I'm going to get 0.666. This is the next x value for the next iterations. So, I'm getting 0.666. That means I'm rounding or I'm roaming between 0.666. So, at the end, I'm going to write the conclusion that the approximate root for the given equation is 0.666. Now, I have my third question, that is, find the real root of the equation. And what is the equation here? That is 2x minus log x equal to 7, and directly they mentioned that the root is near to 3.8. Now, let me to find the solution here. So, what I will do? I will write the equation as it is. So, this is nothing but my f of x. So, dear student, further simplifying this equation, I will get log x plus 7 equal to 2x. So, I am going to simplify this f of x further. After that, I want to find out x value. So, x equal to log x plus 7 divided by 2. Now, I know my x naught value because in the question they directly mentioned that it is 3.8. So, this is my x naught value. Now, what I am going to do? I am going to substitute this 308 wherever I am getting x naught. So, log 3.8 plus 7 divided by 2. That means when I take the log of 3.8, I am going to get some value plus 7, and when I divide that one by 2, I will get 3.789. Now, so this is my next iteration. So, iteration 2 equal to pi of x1. So, what is x1? That is 3.789. So, this is my x1. And where I am going to substitute in this equation. So, log of 3.789 plus 1 divided by 2, I will get 3.783. So this is the approximate root. So if I consider both the equation, I have 3 common, 7 common and 8 common. So 7, 8 is common, and I'm going to stop the iteration and I'm going to write the final conclusion that the approximate root for the given equation is 3.785. So these are the some of the solved example of iteration method. In my next session, I'm going to deal with the type of iteration method. So under iteration method, we are going to study bisection method, regular falsy method and Newton-Raphson method. But in my next session, I'll be dealing with bisection method. Anyway, dear student, let's meet in the next session with the new topic bisection method. Until that, keep watching and keep learning. Thank you.